All right, what we're going to do in this section is we are going to talk about subnetting. So let's get started. All right, so what we see here is we're going to consider a couple of things. Number one, CIDR. CIDR you'll often hear talked about as classless interdomain routing. Once you get an IP address that has a standard subnet mask per its class, for instance a /8 for a class A, /16 for a class B, and a /24 for a class C, once you start subnetting it becomes classless. And that's where you get the classless part of that. And so that's one term you'll see in this presentation very likely. Another thing that you'll see in this presentation is either the prefix or the classful prefix. What we're going to do in this presentation also is we are going to construct a matrix. And this matrix is very useful when you are attempting to do a very quick subnet creation. It's going to lead eventually to what we call the ultimate subnet chart. But first we have to start with creating the matrix. So what you'll see in the matrix is that the far column is going to be for our hosts, and what you'll see is a little subtract 2. You actually subtract 2 from the number that you use to get the hosts. And to determine these numbers, you're going to need to know how to count in powers of 2. So for instance, if you borrow 1 bit, you have 2 networks. If you borrow 2 bits, it's 4 networks. 3 bits, 8 networks. 4 bits, 16 networks. 5 bits, 32 networks, etc. The same thing applies for hosts, except for that for each one of those numbers, you'll need to subtract 2. We'll see that in just a moment. What we're going to do, networks that we need, we circle the row. I know a lot of this does not make sense at this point, but we will show you how it's going to make sense starting with the next slide. So let's have a look at that. This is the matrix of which we speak. If you look up here where we have /25, that /25, what it is, it's a 25th bit and a 32-bit IP address. If you go all the way down to here, we get down to the 32nd bit of that 32-bit IP address. And so what we see in this matrix is that we're looking at 8 bits. We're looking at the last octet. And in that last octet, we have bit number 1 right here, bit number 2 in that octet right here, all the way down to bit number 8 in that octet. Another thing that's going to be important for you to memorize and be able to reproduce is the possible subnet masks that are available in any given octet. And they start with 128, go to 192, go to 224, 240, 248, 252, 254, 255. So those are the only possible subnet masks in any given octet. And then we go to a very important section here. This is the block size. The block size, or sometimes I will note them as count bys, because you're going to be counting by this amount to come up with your subnets. And it starts with 128. And if you look at this chart, it's built just like you would build a chart in order to convert decimal to binary and binary to decimal. So very similar to that. 128, 64, 32, 16, 8, 4, 2, 1. You're just either going from the bottom up, you're doubling the number, powers of 2, or you are taking the 128 and having it all the way down to 1. Okay, this is just the powers of 2. And the hosts over here, we have 128, 64, 32. If I used 3 bits that you see on this side over here, I use 3 bits for subnetting, I would have 5 bits left for the host side, and that would give me 30 hosts total. Okay, so what you do with a chart like this is you do quick lookups. So if you're on the test and you see that you have to borrow 5 bits, what subnet mask is that going to be in the 3rd octet? .248, right there. You don't have to think about it. You just looked at it, and you got it. Okay. How many hosts would you have left? You would have a total of 8 minus 2, so that's 6 hosts left in that network. One of the things you want to make sure that you do not do on the CCNA exam is think. You want to just know this stuff cold, and this chart is a way to help you with it. So let's see how you would use this chart. Let us suppose that you were told that you needed to have 12 networks. 12 networks. Well, what would you do in order to get 12 networks? Well, what you would do is you would count in powers of 2, 2, 4, 8. That's 3 bits. That's not enough. 3 bits is not enough. 16 networks would give you 4 bits, so you would choose that row, circle it, and right away doing that, you know that the notation for the prefix is /28. You know that you're going to use 4 bits. You know that the mask is going to be .240 in the 4th octet. You know that you're going to count by 16s, which is very common, and I'll tell you why in just a moment. And you're going to have 14 hosts left on each of the networks that you have. Each of the 16 networks, 14 hosts. That's 16 minus 2. So just by circling that, you already know a lot of answers to possible questions. But what we want to do now is produce the subnets that you're going to need for the exam or for your job where you are producing subnets. And some people ask me, would I ever need this in a real job? And the answer is, of course, you would use this in a real job. And that depends on the type of job that you're using. For instance, if you are a field engineer and you get airdropped into a situation where you have to immediately figure out how to set up networks, then knowing how to do this stuff is critical. And there are other jobs that you would do this without looking this up on the internet or on some major network or in some software. Okay, you need to be able to do this yourself. So we circle that row. This is the one we're going to focus on. So what we're going to do now is from the count by column, we're going to count by that number horizontally. What does that mean? So we're going to take that count by that we had, which was 16, and we're going to count by that number, starting with 0. So we start 0, and then we go to 16, and then we go to 32, and then we go to 48, making a horizontal roll with space in between until you get to the network you need. So if you are trying to find a particular address in a particular network, then you just go one past that network, which we'll see in a moment, and then you'll be able to create those subnets. Now we subtract 1 from the last number that you have in your row and put the value under the previous number, and you keep doing that until you get back to the first column. And this gives you your broadcasts and your network numbers. Let's see how this actually looks. Okay, so the first thing that we do is we start counting by the block size. So we count starting with 0. Why do we start with 0? Because with Cisco devices, and indeed with most high-end routers and multi-layer switches, you can use subnet 0. So we start with 0. And then we go to 16, 32, 48. And be careful that you don't just jump to 64. Okay, so 0, 16, 32, 48. So on a sheet of paper, you might write this going horizontally. Now I'm writing a 64, I'm writing an 80, writing a 96, writing a 112, writing a 128, writing a 144. I have that all written down, scratched out on a piece of paper. That's the only line I have. Now I drop below that, and below the previous number, which is that 128, below that 128, I subtract 1 from 144, and now I have my first network and broadcast for the 128 network. Okay, so my first network and broadcast addresses. This is why we subtract 2 when we are getting our host bits, because we have a network and a broadcast. All right, so then we go to the 128 and we subtract 2 from that, and that gets us to the 127 right here. Then we go to the 112, subtract 2 from that, that takes us to the 111. And we keep doing that all the way down until we have the entire chart filled out with the network number and the broadcast number. And as you can see on the far right side, it says bcast and net. So now what we have left to do is determine the first and the last hosts, and that is very simple. What we're going to do is, if you look at network 16 here, we're going to add 1 to 16 and subtract 1 from 31. That's our first host and our last host. Now, what this means is on a given IP address, what I'll be able to do is I'll be able to use, for instance, 192.168.103.17. Of course, it has to have the right mask. 18, 19, 20.21.22.23.24.25. .26, .27, .28, .29, all the way to .30, I can use all of those. Those will have to be in one VLAN or off of one router interface because it's all in the same network. I can't go to 31 because 31 is a broadcast address. So I can go to a separate VLAN or a new router interface and then start using those addresses. Like, for instance, I might use .33 for the router interface and maybe .34 for the VLAN interface for that subnet, and then maybe .35 for a server in that subnet. So that's how we assign them. So we just fill in the rest of these. And on an exam, if, for instance, I'm asked to come up with an address or some information, like, for instance, they might want the first and last usable IP address in network 48, then what I would do is I would count 0, 16, 32, 48, 64, and then I would subtract 1 from 64, getting my 63, and I would just fill in this column here and leave that ready for the next question I may get regarding IP addressing. So this would also answer questions like, is 192.168.103.47.127 with a subnet mask of 255.255.255.255.240, is that a legal address? Well, what do? Well, I go and find that column, and I look at that column, and sure enough, with the 112 here as the network number, 127 is actually a broadcast address. So no, it is not a legal address. All right, so let's try another example. This time, we need 4 networks. So if we borrow 1 bit, that would only give us 2 networks. If we borrow 2 bits, that would give us 4 networks. So what do we look at? We look at borrowing 2 bits. So here's the 2 bits we're going to borrow. It's going to give us a mask of .192. It's also going to give me a block size of 64. And with a block size of 64, that means I'm going to count by 64. So block size is the count bys. All right, so let's count by 64. Here we have 0, 64, 128, 192. And then we subtract 1 and put it into the next column. Again, we do the same thing with the 128. Subtract 1, put that into the next column, so that's 127. We go to 64. Subtract 1, put that into the next column. That is 63. And then we fill in our first and last usable addresses, and there we go. So the second usable network is the 64 network. The third usable network is the 128 network. So if you're asked a question, please find me the first and last usable addresses on the third network. Given these characteristics, then I will go to this network and I give you the first and last usable addresses. All right, so now this is all addressing using Class B and Class A addresses. And so now we need to go into and have a look at what you do with Class B. So we've been looking at Class C addresses, and we're going to look at Class B addresses now. So for a Class B chart, you'll need to leave room for the last octet, because in Class B, the object that we're focusing on, the octet that we're focusing on, is the third octet. So you need to leave room. So instead of doing a simple count of 0, 64, 128, like we would if we were dealing with a Class C address, we would do 0.0, 64.0, 128.0. So we must leave room. this is how that would look. All right, for a class B address, we would do 0.0, 64.0, 128.0, 192.0. And here is the tricky thing right here. When we subtract 1, it doesn't just go to 191, it goes to 191.255. It doesn't just go to, after subtracting from 128, it doesn't just go to 127, it goes to 127.255. It doesn't just go from 64 to 63, but from 64.0 to 63.255. And then it's tricky again, or trickier, it's not that bad though, when we add one number. So we add to 64.0 to move 1 up from there, it's 64.1. As you can see, the third octet numeral is still the same. And also from the broadcast, we subtract 1, and now we have 127.254. So again, the third octet, 127, is still the same. So that can be a little bit tricky, and so you just have to look out for that. Now, the next thing we want to look at is, if you want to have the most success, you need to memorize the following table. So memorize the following table. This is the ultimate subnet chart. All right, so we have a mnemonic right up here. And what you need to do is we're going to use this mnemonic to help memorize the columns. So we have the count by column. We have the mask column. We have the CIDR column. We have the host column. We have the BNets column and the CNets column. All right, so the way to write this down is in the count by column. It's just the same thing you would do if you were doing binary conversions. So 128, 64, 32, 842, 1. And then, since that was the third octet, we move again to 128, 64, 32, 16, 8, 4, 2, 1 in the fourth octet. So that's the first thing you do. And then what I normally do is put together the BNets and CNets and the hosts. And doing the CIDR numbers are easy. You just start after 16. You go to 17 all the way out to 32. And again, you have to have your masks memorized to make this work also. So this chart, why in the world would you want to remember this chart? Here is why. You have a Class B address. You need 900 hosts at least. What would be the characteristics of that network? So I need 900 hosts. I just go to the host side here. 900 hosts. Actually, I would, if I used a /22, that would give me 1,022 hosts. That would give me 64 networks with a Class B address, with a 252 in the third octet for the subnet mask, and a 0 in the fourth octet for the subnet mask. And I would count by 4s. All right, so let's say I'm in a Class C network, and I need at least 13 networks. Well, I go down to the CNets column, and 8 is not enough. 16 is fine. So if I borrow 4 bits in that column, then what will happen is that will give me, I have to skip the BNets because that doesn't have anything to do with C. That would give me 14 hosts. It's going to be a /28 mask or .240 in the fourth octet. And I would count by 16s like we did before. Well, let's get another one. Let's say you had a Class B address, and you need to have at least 1729 hosts. 1729 hosts. Kind of an esoteric number there. Well, I would have to go to 2046 on the host line, and then that would give me a /21 network, a .248 in the third octet, and a .0 in the fourth octet. And I would count by 8s if I needed to, and it would give me 32 networks. So you can identify these things very easily with the ultimate subnet chart. All right, so what this gives us is a very fairly simple way to do subnetting without having to do much math. I have to do a little bit of memorization, but you can do that. All right, so that's the end of this presentation. If you have any questions or if you have comments, post them. Do well in the test.